Chapter 17, Lines in the Plane and Space. What we're going to do in Chapter 17 is combine everything we learned about vectors. So we begin by a quick recap. Remember, there are two ways we write vectors, in component form and in unit vector form. Remember, component form is when we write it as a matrix, and the top number is what we call the x component, and the lower number is what we call the y component. In unit vector form, we just write it using the unit vector I and the unit vector j. I believe your book will call it A1I plus B1j. Remember, the A1I tells us to move left and right. The B1j tells it to move us up and down. Likewise, the x component, we move along the x-axis, and the y component, we move along the y-axis. Now, directional vectors let us know two things: what direction we are traveling in. Now, it's important to note that a directional vector only tells us what direction we are traveling in. That's all it tells us. It should not be confused with the velocity vector, which tells us what direction we are traveling in and as well as the speed we are traveling. We'll get more on velocity vector later. So for right now, all we're working with is a directional vector. So how does the directional vector work? Well, first of all, remember your coordinate system using north, east, south, and west. Notice that the west and the east is along the x-axis, and the north and south is along the y-axis. So the x component tells us to move east if we're positive and west if we're negative. Again, x component, east if I'm positive and west if I'm negative. The y component tells us to move north if we're positive and south if we're negative. So along the north side if we're positive, and along the south side if we're negative. The directional vector 1, 0 tells us to go 1 unit east, just 1 unit, and 0 units north. The directional vector 0, 1 tells us to go 0 units east and 1 unit north. So if we look at this carefully, 1, 0, 1 unit east, but 0 units north or south. If I look at this vector 0, 1, not going east or west, but just traveling 1 unit north. An example would be here. If a boat travels in the directional vector of -7, 5, then the boat will travel as such. Now, before we begin, we have to start off with the position. I'm just going to consider this point right here the position of the boat. And the boat will travel -7, so 7 units in this direction. And then it will travel 5 units in this direction. So here I have -7, or 7 units towards the west and 5 units towards the north. The actual direction of the boat is now traveling in this direction. So if we were to look at this boat travel, it would just simply be going like this along the high seas and continue in that direction as such. Moving on, plot the following directional vectors. Do me a favor and try to plot these directions. Just hit the pause button and wait a few seconds. Hopefully you tried to plot a few of these, so let's begin. First, let's start off with A, -3, -2. So first of all, I pick any arbitrary spot I want to be in. I'll just start here. So that means that the object A will be going 3 units negative, 1, 2, 3, or 3 units west, and 2 units south, or -2, 1, 2. So that means that vector A has a directional vector going in this direction. Vector B, right here, will be traveling -2, 4, or vector B will be going -2 units east. Oh, before I begin, I better pick a spot. I'll start here for vector B. So I will be traveling -2 units, 1, 2, +4 units, 1, 2, 3, 4. I kind of picked a bad spot for B, but oh well, we could work with it. So that means that vector B is traveling in this direction. Now vector C, which is right here, will be traveling in the direction of 3, 7. So first I pick a spot where I'm going to begin, and I'll just pick this spot right here. And vector C will be traveling 3 units towards the east, or +3, 1, 2, 3, and 7 units up, or north, 1, 2, 3, 4, 5, 7. So here's where I'll place vector C, traveling in this direction. So here we have the three directional vectors of A, B, and C. How this works is kind of simple. I'm sure we all been to the movies where you see some airplane flying through the air and all of a sudden the pilot here is like, Johnny, you got a bogey at 5 o'clock. So Johnny, the pilot, what he does is he imagines the clock and he puts 12 o'clock in the direction he's traveling. So he turns his head to 5 o'clock, and that tells him that the bogey is somewhere along this path. Notice it doesn't tell him exactly where the enemy is, just somewhere on this line. Unit from this angle, where Johnny is going in this direction, and the 5 o'clock bogey is taken from, now again, he turns his head, not the plane. So the enemy is somewhere along this direction at 5 o'clock. Let me check our time here. Oh, 7 minutes. I still have time, I think. Oh, no, I don't. So this concludes directional vectors, and please watch the next video.